Welcome to January 6th LeetCode Challenge. Carpooling. There is a car with a capacity empty seats. The vehicle only drives east and cannot turn around and drive west. You're given an integer capacity and an array trips where trips at I is equal to the array number of passengers from I to I, where I indicates the trip has number of passengers. The locations to pick them up and drop them off are from I to I, respectively, and the location are given as the number of kilometers due east from the car's initial location. Return true if it is possible to pick up and drop off all passengers for all the given trips, or false otherwise. Alright, so basically, overall idea, the car's driving east. We're given an array of three numbers, number of passengers, the pickup location, and the drop-off location. And we want to know if it's possible to keep on traveling east while dropping off and picking up and dropping off people in that order. Alright, and the only condition is that we cannot turn back or drive west. So we have number of trips, which are given as basically number of passengers from to, and we have basically 2 trips, and the capacity is 4. Can we, first of all, the number of empty seats, that doesn't work, because we're picking up basically 2 passengers, dropping them off location 1, and then picking up at location 1 and dropping off at location 5. However, in between 1 and 5, there's location 3, but we're picking up 3 more passengers, so that means we have 5 number of passengers, which outweighs the number of capacity of number 4, so false. Okay, let's see example number 2. Capacity is 5, and the number of passengers is 2. At maximum most is 2 plus 3, which is 5, so that's fine. We pick up from 1, drop up at 5, pick up from 3, drop up at 4, so the answer is true. So everything heading east, we can meet all the capacity and all the pickups and drop off location. Our constraints. Alright. Show hints. Sort the pickoff and drop off by location, then process them in order. Sounds like a good idea. Let's do that. So, let's think about, the approach itself is just basically going from east to west, and then seeing the number of pickup and drop-offs. If the pickup location, the capacity fits the number of passengers. Ideally, if the car has a capacity of 2, it picks up 2 members, drops them off at 1, and picks them up at 1 and drops them off at 5. And then there's a pickup location at 5 and dropping off at 7. That should, if all the members are dropped off, ideally the capacity they could hold. Once all the passengers are dropped off, the capacity becomes free again. The number of seats are free. So that's kind of like the idea. So the first thing we want to do is let's follow the hint here, where we have to basically sort the pickups and drop off by location and process them in order. Let's do that. So the first thing I want to do is create an array of empty array for passengers. Let's call that an empty array to initialize that. So for the number of passengers and the from location to the to location, let's see, from is a keyword. Let's call that F and T. So number of passengers from to location in trips. right? These are the three items inside the list. We are going to reorder the passenger. So we're going to make a new array, passengers.append. We are going to append the tuple of from one and number of passengers. And then we are going to do passengers.append to location to 0 and number of passengers. So ideally, when we pick up from the location, the number increments by 1, and then if we drop the members to a location, we decrement, the number goes down by 1. Alright, so next thing we just do is sort it, passengers.sort, and we want to keep track of the actual number of capacities we have, or the number of seats taken. So we'll call this actual number of passengers. Initialize that to 0 initially, because the car starts off on the left east side and it's empty. And then we do for each position, we need to know the marker. So that's basically the index, right? So the position, whether it's from or to, we need to know the marker, whether it's 1 or 0, and the number of passengers in passengers. So if the marker is equal to 0, so that means it's to location here. That means we're going to a location. Then we want to basically, if we drop a passenger off, we want to decrement it, the actual number of passengers. So actual number of passengers get decremented by the number of passengers that it has to drop off that location. Else, if it's not 0, then it's 1. That means we're picking up a person. That means that the actual number of passengers is being incremented by the number of people we're able to pick up at the location. And then, like in this instance, if the number of passengers 2 plus 3 is greater than the capacity, then it's 5. Or it's greater than 4, then we want to return false because we can't even pick up the amount of passengers. So if whenever the actual number of capacity of the vehicle is greater than the capacity of empty seats, we're going to return false. Otherwise, return true because we can do this algorithm. Seems good so far. Alright. So time complexity wise is big O of n because we have to iterate through each integer, let's see. Yeah, so we iterate through the for loop here in the beginning to find number of trips we can make, and then we append it. So it'll be big O of 2n because we do a for loop here. Space complexity is big O of n because stores everything is a passenger. So the approach here we did was basically where we can only go east and cannot go west, and we just basically sort the algorithm. Is basically we're using a sweep line algorithm, also known as a plain sweep algorithm, where basically the idea is that we imagine like a field or a line or a chart of some sort, then we go from east to west with a vertical line, and we sweep across the plane, and then basically we stop at the from location and drop off the to location. So it allows you to do like geometric object placements where we intersect with certain pickup location and drop off location in the immediate vicinity. So basically, it allows us to tell if we could pick up the number of people and drop them off while meeting the capacity. So this is the line sweep line algorithm. All right, there you go. Have a great day, guys.